Alright, ladies and gentlemen, here we are, Earthquakes, Chapter 4, Lesson 2. Let's get into it. First thing's the same. I write my name. AVID 6, capital A, capital V, capital I, capital D, number 6. Monday is going to be November 30th, 2020. Our topic or objective, science, capital S-C-I-E-N-C-E, capital F, capital N, capital T, phase, capital P, H, A-S-E, the number 4, colon, summarize, capital S-U-M-M-A-R-I-Z-E. Chapter, capital C-H-P, period 4. Lesson, capital E-L-S, period 2. Blue pen, earthquakes. All the way over here to the left, capital E-A-R-T-H-Q-U-A-K-E-S. Leave a little space, main idea, capital M-A-I-N, capital I-D-E-A, slash, capital E period, capital Q period, colon. Earthquakes are caused by sudden motions along breaks in the crust called faults. So, E apostrophe quakes, Q-U-A-K-E-S, that's another way to say earthquakes. Equal, sudden, S-U-D-D-E-N, motion, M-O-T-I-O-N, along, A-L-O-N-G, faults, F-A-U-L-T-S. We know that faults are breaks in the crust, so we don't need to write all those words down. Okay, first vocabulary word, seismic wave. S-E-I-S-M-I-C, wave, W-A-V-E. It's on page 144, 142, 143, 144. There's the word. Go back. These waves are called seismic waves. What waves? Well, go back further. The released energy travels in waves in all directions, including up to the surface. Okay, so energy waves. But what are they talking about? The plates shudder and jolt into a new position. This causes an earthquake. Okay, so a seismic wave is a wave, W-A-V, of O-F, energy, E-N-E-R-G-Y, spreads in all directions, including surface. Spreads, we're going to indent, S-P-R-E-A-D-S, all, A-L-L, directions, D-I-R-E-C-T-I-O-N-S. So if you think about in your mind like a flat lake with very calm flat water, and you throw a rock out into the water, boom, the waves spread out in all directions, but not just out in a circle, also down deeper into the earth and up toward the surface or the crust of the earth. Okay, next one, seismograph. Oh, well, there's that same seismo. I bet that has to do with earthquakes and waves, but a graph is like measuring or putting something on a graph. S-E-I-S-M-O-G-R-A-P-H. Seismograph. Seismograph. Page 146. A seismograph detects and measures the amount of ground motion during a quake. Detects, D-E-T-E-C-T-S, and, down 3 down, measures, M-E-A-S-U-R-E-S, ground motion, G-R-O-U-N-D, indent, motion, M-O-T-I-O-N, detects and measures ground motion. Okay, let's go back to the first page in our first section in red. At the faults. Skip a line, capital A-T, faults, capital F-A-U-L-T-S. Pencil, Movements in Earth's crust are usually so small and slow you can't even feel them. But at times, these movements can be quick and violent, causing sudden and unexpected changes to Earth's surface. Such movements typically happen at faults. Remember that faults are cracks in the crust, typically along plate boundaries. Okay, so crust, C-R-U-S-T, usually, U-S-U-A-L-L-Y, moves, M-O-V-E-S, slowly, S-L-O-W-L-Y. Can be sudden, S-U-D-D-E-N, arrow, earthquake, E' quake, Q-U-A-K-E. Along faults, A-L-O-N-G, faults, F-A-U-L-T-S, and faults are cracks in the crust, typically along plate boundaries. So squiggle, boundaries, B-O-U-N-D-A-R-I-E-S. So, crust usually moves slowly. It can be sudden, which means it's an earthquake. It usually happens along the faults, and those are basically along the plate boundaries. Make that A clear. Earthquakes are one of these sudden changes. Why do earthquakes happen? The answer lies with the stress that builds up in rocks along faults. As you study the types of motions along faults, think about how rocks deep underground are affected. Okay, so stress builds up. Stress, S-T-R-E-S-S, builds, B-U-I-L-D-S, up, U-P. So instead of things being able to move, they push and grind and rub against each other. And then as they're moving and slipping, it's kind of like snapping your fingers. They're pushing and sliding, and then suddenly, snap, there's an earthquake. On October 17, 1989, a powerful earthquake struck Northern California. It shook apart this freeway near downtown Oakland. Okay, so Mr. Rob was 8 years old when this happened. I was in basically 3rd grade, and I saw this happen on TV. And then I've lived in Oakland. I have seen this freeway after it was rebuilt. Types of faults. Red pen, skip a line, capital T-Y-P-E-S, of O-F, faults, F-A-U-L-T-S. Well, I think we already know the types, don't we? Don't we know convergent, coming together, divergent, pulling apart, and what was it, slip faults that slip past each other? But maybe those were the names for the plate boundaries. Maybe it's going to be something different. Let's find out. Faults can be classified into 3 main groups. The groups are based on the type of force that forms the faults and the way they move. Look at the drawings at the right. Okay, so they're based on the force and the movement. Based, B-A-S-E-D, upon, U-P-O-N, force, F-O-R-C-E, and down 3 down, movement, M-O-V-E-M-E-N-T, movement. Okay, let's look at the pictures because that's what they told us to do. Different types of faults. Normal, reverse, strike, slip. Okay, let's see. Normal. All right, I think we're going to have to put those on the sides here, right? We don't know how much space we're going to need, so let's go left and right like this. Normal, capital N-O-R-M-A-L on the left. Reverse in the middle, capital R-E-V-E-R-S-E. And then strike, slip on the right, capital S-T-R-I-K-E dash slip, S-L-I-P. All right, let's draw some pictures. Okay, normal looks like, let's see, we've got that and that. This arrow kind of goes up a little bit. This arrow kind of goes down a little bit. Hey, that looks like one going up and one going down. That looks like a fault block, doesn't it? And then arrows pulling apart, arrows pulling apart. So to me, that looks like fault block mountains that are going to form. So FAULT-BLOCK, mountains, MTNS period, and that looks like divergent, 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 divergent. Okay, let's draw a picture of the reverse. So the one on the left is a little bit lower. The one on the right is a little bit higher. This one's going down, this one's going up, and these arrows are pushing together. Okay, again, that looks like a fault block mountain. So F-B MTN period. But they're coming together, so that is convergent plate boundaries, right? CONVERGENT. Okay, let's look at strike slip. Aha! This one's going to be a little harder to draw. Let's do the one on the right first. And then this comes out at an angle, out at an angle. This line needs to be parallel with this line. Those two lines are parallel with each other. And then this line is flat. And now we can continue the fault that way. Okay, an arrow going here, an arrow going up and to the right. And I'm going to go back and look. What were those called? Let's go back in our notes. Okay, looking back at Chapter 3, Lesson 4, Plate Boundaries, that looks like transform fault. So let's go ahead and write that. Oops, not an F, I want a T. TRANSFORM dash fault, FAULT, transform fault. All right, where were we? Words. As sections of the crust move apart, rocks are stretched until they snap, causing one block to move down along a sloping crack. Okay, so these two are pulling apart. Eventually it snaps and cracks, and one piece can fall down. What would be a good example? Like, you could take string cheese and pull it apart, and eventually the cheese would, like, snap apart from each other. Plastic can do that also if you can stretch the plastic hard enough, or Play-Doh, or silly putty. Reverse. Rocks are compressed as they come together, causing one block to move up along a sloping crack as the other moves down. Okay, so this kind of reminds me of the fault block mountains. It also could remind me a little bit of like the fold mountains maybe, pushing together, and as they push together it'll eventually snap and slide up. Okay, strike slip. Rocks grind against each other as they move horizontally past each other in opposite directions. Pressure builds up along the fault until the rocks break. So that's kind of that finger snapping example, right? My fingers are pushing past each other and eventually they snap and slide past each other. In slow motion, they're sliding past each other, but in fast, they're pushing, they're sliding, and then they snap. All right. So we don't need to talk about the moving apart because that's divergent. Stretch until snap. Let's put that. STRETCH until UNTIL snap SNAP. Causing a block to move down along a sloping crack. Yeah, we see that in our picture. Compressed as they come together. Ooh, let's say that. Compress. COMPRESS. Pushing or compressing together. Causing one block to move up along a sloping crack as the other moves down. We can see that in our picture. Rocks grind against each other. Ooh, let's say that. Let's use that word. Grind. GRIND. Move horizontally past each other in opposite directions. Horizontal. HORIZONTAL. Pressure builds up. Pressure. PRESSURE. So if they're moving apart, they're stretching, but if they're compressing or grinding, they're building up pressure. Normal faults occur at or near divergent boundaries. Did we get that right? Normal? Divergent? Good. Places where the Earth's crust is being stretched apart. Eventually the rock breaks. A fault forms when one block moves down the edge of a sloping crack. Okay, so we can see that fault. Most normal faults are small, with blocks of rock moving down by just a meter or so. Some faults, however, extend across many kilometers. In western United States, normal faults run along the edges of several mountains ranges, such as the Tetons and the Sierra Nevadas. Mid-ocean ridges are also typical locations for this type of fault. Okay, so they can be small, SMALL, all the way up to many, MANY, KM for kilometers. So it could be small, like a few meters, like the size of our classroom, to as long as, the entire coastline of the United States. Reverse faults usually occur at convergent plate boundaries. Okay, reverse convergent, we got that correct. As the rock breaks, one block is pushed up along a sloping crack. We can see that rock pushing up along a sloping crack. This type of fault often occurs in regions where one plate subducts below the other. So usually over here is going to be SUB, DUCT, ION, subduction. You know what that means. There's going to be hot spots, magma plumes rising to the surface, creating dome mountains, or possibly erupting through in volcanoes. Okay. Strike-slip faults occur where tectonic plates slide past each other at transform fault boundaries. Transform fault. Okay, so a strike-slip fault occurs at a transform fault boundary. Right, so these normal reverse strike-slip are the name of the fault. Divergent, convergent, transform fault are the name of the plate boundary. In contrast to the other two types of fault, the movement is horizontal, thinking about the horizon of the Earth where the ground meets the sky, flat, as one block grinds past the other. California's San Andreas Fault is a strike-slip fault. Okay, let's put that because that's such a famous fault. Capital S-A-N, Andreas, capital A-N-D-R-E-A-S. Okay, we got all of our pictures and our notes. What happens when stresses build up along a fault? All right, when stresses build up along a fault, there can be sudden changes resulting in earthquakes, right? Pressure can build up and cause grinding. Okay, let's say that differently. When stresses build up along a fault, stress builds up along a fault, there can be sudden changes resulting in earthquakes. At a normal fault, the rock stretches until it snaps. In a reverse fault, the ground compresses and ends up sliding up over the top of one another. And at strike-slip faults, the pressure builds from grinding past each other. Okay, that's pretty good, something like that. All right, that's it for the first day. Good job persevering with the growth mindset. Roar Wildcats!